Limits describe where the y value of a function is approaching as the x value converges on a point. In this example, the y value as x approaches 0 from the right is approaching the value 2, and as x approaches from the left is also approaching the value 2. Hence, the general limit in this case is 2. Even with a hole, the limit can still exist because the limit is approaching the coordinate of the hole itself and not the hole. So in this case, as x approaches 1 from the left, it's still approaching the y value 1, and as x approaches the value 1 from the right, the y value is still also approaching the value 1, meaning the general limit exists and is equal to 1. Even as x approaches positive or negative infinity, the limit can still exist. In this case, as x is approaching positive infinity, it's approaching the y value down here, which is the horizontal asymptote. However, in this case, as x approaches 0, the y value is approaching positive infinity, which is not a real number, meaning the general limit does not exist. For functions in which the y value isn't approaching a specific point, the limit does not exist. In this case, because the graph is oscillating between negative and positive 1 and never settles on a specific point, the limit cannot exist because it just keeps moving up and down at a faster and faster rate. Now, let's take a look at piecewise functions. In this example here, as the limit approaches 1 from the left side, the y value is approaching negative 1. However, on the right-hand limit, as x approaches 1, the y value is approaching positive 1. Because the left-hand limit and the right-hand limit do not agree in this case, the general limit does not exist. Now, if you need more help, check out our other video on the application of limits linked down below.